Okay, so had a pretty wet August in some parts of Nebraska. Which areas of the state saw the most rain?
Basically the central third of the state from north to south, and really what we had was a battle zone between high pressure to the west and low pressure to the east, and so everything funneled from North Dakota right straight southward to basically eastern Oklahoma, and everybody within that zone, 100 to 300% of normal precipitation was very common.
Then when you look at central Nebraska specifically, that portion of the state saw a lot of clouds, but it wasn't rainy. Why was that?
Well, the other thing you have to consider is that as these systems move toward the south, and a lot of them were overnight convection, they kind of lose their punch. And so a lot of these storms were moving through the central part of the state in that 3 to 6 o'clock in the morning range. And generally, if you look at thunderstorm convection, it peaks during the late evening to the overnight hours, then wanes as the atmosphere recharges itself. And so as it moved south of the state, we started to see the precipitation totals drop off. So really the heaviest core of the precipitation was central and northern Nebraska, with lesser totals as you move toward the Kansas border. Although we did see a few isolated pockets of heavy precipitation, the broad base of that area was significantly less than what we saw in central Nebraska.
And when your office is trying to measure cloud cover thickness, how do you do that exactly?
Well, what we do is we don't actually measure cloud thickness as much as we measure the total global solar radiation that's coming to the surface. So we're actually measuring, to an extent, the short-wave radiation that's making it through the clouds to the surface. So we don't look at surface depth as much as the total impacts of the thickness of those clouds and how they impact solar radiation coming through them.
And could you give us an overview of the solar radiation levels that were measured in August?
Yes, and that's the one thing. When we looked at the state as a whole, there was only 2 locations that were above normal in terms of solar radiation: Scottsbluff and the northwest corner of the state. The center part of the state was the worst hit. We'd typically seen for the month, and this is generalizing, between 15 and 25% reduction in solar radiation. But within that third full week of August, we had locations in south central and central Nebraska that received 1/5 of their normal solar radiation on the 24th and the 25th. Very heavy clouds, real foggy, and a lot of mist.
And you've also written about the Langley. So what is that exactly, and why is that something that a farmer needs to know about?
What a Langley is it's an English term for basically energy, measurement of energy at the surface. So commonly the term in metric units is watts per meter squared. A Langley is so many watts per meter squared. So yes, we haven't converted to the English measurements. We're still under the old Langley guideline, but that has been the status quo for the last 30 years, and we'd hate to change in midstream, even to SI units, when most of the United States has been using Langleys as a measurement for solar radiation for the past 30 years.
And in regards to that solar radiation, what happens to the crops as that solar radiation decreases?
Well, this is kind of a double-edged sword. Generally, you would think that solar radiation, particularly central Nebraska and westward, where we have a lot of irrigation, we like to have nice sunny days, cool nights, clear nights, so it goes through its normal respiration. When you increase clouds during the day, of course, you don't get as much solar radiation and energy absorbed into the leaf matter. But in the same token, you can extend your grain fill process. So the most important key issue is that during that time period after you're going through your pollination period and your grain fill, so basically we're talking about that period in September to early October at the tail end of the season. If you don't get too warm, that extending of that grain fill process could become benefit. You get heavier kernels. But if you turn warm and dry, you can speed up that process and you have less grain fill. So I think the big issue this year is if we start to see some problems with yields outside of the normal bacterial problems, viruses, green snap, insects, we're most likely going to find that the solar radiation, decrease in solar radiation, did have an impact. In fact, I've had a few reports from some of our producers that they're trying to tie some of their yield expectations that are below where they thought they were going to be to the very cloudy conditions we've seen during that week 3 and to some extent the middle of week 2 to the beginning of week 3. So it was about a 10-day period there was exceptionally cloudy, and things really just stood at a standstill.
And you think that yield loss because of the decrease in solar radiation is specifically going to impact central Nebraska?
If it's going to have an impact, I would think that that's going to be where the vast majority of the impact. But the problem we have there is we've been persistently wet, so you're going to have to try to offset that with the impacts of the extreme wetness, the wind, the hail, and the disease issues. All of those are key players this year. So isolating out a single instances of that solar radiation was caused most of yield reductions, if we do have real yield reductions there, is going to be a difficult process. But I think it is a player. And in the past, agronomically trained, this is one of the things we always were key to look for, is a lot of cloud cover during grain field can lead to some serious problems, particularly if the season is cut short. So those areas to the north of us also had problems with solar radiation, and their crops are even farther behind than ours. So I think that that's where we're really going to see the real issue with this, is that it cut off a lot of maximum temperatures, so it extended the period for grain fill, but it reduced the speed of which it would have went through the grain fill process, so it extended the season. And extending that season this year for late planted crops is a dangerous proposition.
Any idea on specific spots where that could be seen? I know we just say central Nebraska, but any specific spots there?
The area from Central City all the way down through Clay Center and about one county, both sides of that, is where the core of the intense solar radiation decreases were, and where our major daily solar radiation decreases were. You can't find a site within the eastern 3/4 of the state that didn't even have at least 1 to 2 days where we were 20 to 30% lower than normal solar radiation, but we would expect to see that in any given month. But the extent of day upon day upon day is the key issue here.
And looking ahead, we'll have you get the Owl Dutcher crystal ball out. How's winter weather looking?
Unfortunately, what I do see is a very active pattern materializing. The difference between this year and last year in the equatorial Pacific is that we have a larger cold pocket in the eastern equatorial Pacific, kind of supporting that high pressure system in the southeast. It's been blocking the movement of cold air across the country. So we get this trough in the west, and as long as that pattern holds, and typically these patterns they start to set up, last between 6 to 8 weeks, I would say that the first half of this winter is likely to be very stormy. The northern and central plains most likely are going to be the beneficiaries of some heavy snowfall. A little bit more uncertain as we go to the south of us. I would say eastern Kansas may be in pretty good shape, but the western part of those states and toward the southwest of there, I would be worried about getting dry conditions developing. We don't look to see as many surface lows coming in through the southern stream like we did last winter and then ejecting to the northeast. These seem to be coming into the Pacific Northwest and then ejecting as they dig into the southern Rockies to the northeast. That's a whole different ballgame because you're not bringing the Pacific moisture into the southern Rockies. So if that is the case, and if we follow the classic cooling of the equatorial Pacific and start to watch the Gulf of Alaska cool, then we would start to worry about La Nina conditions as we go into next growing season. And classically, most La Nina seasons, when we are into them, end as a dry winter, colder than normal. Then we do see some storminess during the month of March, but we also usually see a fairly early break in our winter conditions. And generally, the April period tends to be drier than normal, which after the last couple years would be a welcome benefit to most of the Nebraska producers.
All right, thank you, Al.
You bet.
Appreciate it.